Okay, this AP Calculus, another optimization problem. This has to do with a farmer in his corral. It says that a farmer has 400 feet of fencing with which to enclose two adjacent rectangular corrals. What dimensions should be used so that the enclosed area will be maximized? First thing I'm going to do is just start making some notes to myself. The first thing I want to know is what has to be maximized or minimized. So that's this right here. And then also we have a constraint here. We have only 400 feet of fencing to use. So I'm going to go ahead and read through the problem a little bit. There are two adjacent rectangular corrals. So I think that the corrals would probably look like this. So here's my diagram. This actually helps on the exam, I think. And they're going to look like this. And here's, if it was just one of the corral, it would look like this. But they're two adjacent corrals. So let's say that they look like this. If you don't mind, I'm going to have this is X and this is X and this as Y. So we know this, and when I start putting this together, that we know that the perimeter of this thing has to be 400 feet, because that's the constraint we have in fencing. So there's our perimeter. And our perimeter is going to be 1, 2, 3, 4 X's, so 4X, right? Plus, and this is where I think they're trying to catch us, is these Y values. So here's one piece of fencing here. There's another one, and there's a third. So plus 3y. The next thing that we have to take into consideration is what's the area, because that's what we're trying to maximize. We're going to maximize the area. And the area is, this thing has a width of 2x, right? This whole value from here to here is 2x, isn't it? And then its height is, or its length here is y. So the area here is equal to 2x y. So this is our secondary equation, often called a constraint, and this is our primary. So I get this done like this. Now what I'm going to do is I'm going to solve the secondary in terms of one of the equations. So I'm going to solve this one for y, and if you solve this for y, just do the algebra here. So I'm taking this function right here, this secondary function right here, say right there. I'm going to solve that bit inside for y, and it turns out that y, wow, I really said that, yeah, y is equal to 400 minus 4x all over 3. Isn't that right? And then what I'm going to do is, so that's this in terms of that, and I'm going to substitute that back into this equation. So I'm going to let, this is where I am right now, I'm going to let this y right here be this y right here. So I'm going to rewrite my primary function. Now I'm going to have perimeter and area all in one function. So I'm going to say that the area is equal to 2x times, and we have our y value, right, is this, so is 400 minus 4x all over 3. Going to simplify that equation out and get that the area is equal to, what is that? Oh my gosh, 800x. I'm going to end up factoring this out, I bet. Minus 8x squared, is that right? Yep, minus 8x squared all over 3. Now, I'm just looking at this, and what I'm going to want to do is I'm going to want to differentiate this, I think. So what I think I'm going to do is I'm going to rewrite this one more time, and I apologize, but I'm just figuring this out, is I'm going to take this 8/3. I'm going to factor the 8 from here and here times 100 minus, 100x minus x squared, right? I think that's good math. And now, because we're trying to maximize this, we're going to take the derivative and see where we have a critical value. So take a prime. This 8/3 is a constant multiple, isn't it? The first derivative of 100x is just 100. And the first derivative of x squared is negative 2x. Isn't that right? And remember, when we're looking for a critical value, you're going to set this thing equal to 0. And this thing equals 0 when x is equal to 50. So here we're looking for our dimension. So x is 50, so it's a 50 by something. And then what would I do? I'd go back up here, and I would do this. Right, I have 400. This is my perimeter equation, is equal to 4x plus 3y. Let x equal 50. So x is equal to 50 here. So 200 is equal to 3y. y is equal to 200 thirds. And let me just take a quick look. We're done, I think. We're done. We have feet of fencing. That's what I was looking for. So now I have to answer the question that was asked. So dimensions are 50 feet by 200 over 3 feet. And there's our answer. So look, I hope this was really helpful. Remember, draw a picture, figure out what your constrained equations are, or your secondary equation, your primary. Solve your secondary equation in terms of one of the variables. Plug it back into your primary equation, the one that you're going to optimize. Go back and make sure that you figured out how you're going to optimize. Are you minimizing or maximizing? So that's something to think about. And then do a little bit of work. All right? Look, you guys, I hope this was really helpful. If you have any comments, please make them. And if you haven't already subscribed, please do. Thanks, and good luck.